All right, so now we're back and we're looking one last time. It's been 30 minutes, right, since we first put our ice in. So we know that the water completely melted after how long? How many minutes? 10 minutes. 10 minutes. It was 10 minutes. And then we still have some ice in the milk and the Sprite after 20 minutes, and even now after 30 minutes. So what we're going to do now is we're going to pull the ice out and look at it. We'll see. Here's the Sprite, the ice that was in the Sprite. So we'll set that down to look at it, and we'll pull out the ice that was in the milk. Which one has melted more?
The milk.
The milk. So when we put ice in liquids, it melts much more quickly in water. And then the second liquid that it melted quickly in was Sprite. And then the milk was, which one? It melted the second in the milk. And then it was melted the most slowly, ironically, in the Sprite. Was that surprising to you?
A little bit.
A little, because you had predicted that it would melt fastest in the milk. So tell me your thoughts. Why do you think, by looking at the way it melted, the way that the dye goes through the water and it's just sort of at the top of the milk and the Sprite, what does that tell you about when the ice melts? What happens to it?
The water.
It spreads out through the water, so that cold ice that's melting kind of spreads out, and so probably the ice is always touching the warmer water, right? Whereas here, for example, in the milk, as the ice melts, it stays at the top, so that freshly melted water, which is still pretty cold, is what's closest to the ice. So does that have an impact on how quickly it melts?
Yes.
Yes, it would, because when that cold water stays close to the ice, then it's not in touch with the warmer liquid as much. It's in touch with that freshly melted ice that's really, really cold. Maybe it's 33 degrees instead of the temperature of the liquid. And then same thing with the Sprite. It's the melted ice stayed close to the top. And apparently the carbonation doesn't have that much of an impact on the melting of the ice, does it? Okay. So that's what we learned. And now we know how ice kind of melts in liquids. And what is the purpose of putting ice in a liquid? To make it colder. And you can see when you put ice in water, it spreads through and probably makes the whole drink colder. But maybe when you're putting it in a soda, it just, it makes it colder where it's touching the soda, but maybe not much else. And maybe this is the reason people don't usually put ice in milk too, right? Because it's just at the top. And what would be a way that we could keep ice from melting very quickly in a liquid? Well, what do you think we can do? If we put ice in a liquid, what can we do to make it not melt as quickly? Does it make a difference, maybe the temperature of the liquid?
Probably.
Yeah. What about the amount of ice you put in there? Yeah, because if there's a lot of ice, will it melt more quickly or maybe more slowly? Yeah, so if you put more in, it might not melt as quickly. Okay, well that's our experiment. Do you have any questions at the end? No? All right, thank you. And that's all.